Yeah, g'day and welcome back. Now there's plenty of different ways to touch off on a piece of stock in a milling machine. If you've got a really rough piece of stock, you might just be able to eyeball it, but normally we want something with a little more precision. Now for years, I've used this Starrett wobbler or edge finder, model 827MA. I'll put a link down below. I really like it, it works very well. This is a metric version, I think you can get the same thing in Imperial. And I use that to touch off in the X and the Y directions at the back left corner of my part. And once that's done, it's easy enough to switch to my first tool and then use a cylinder of a known diameter to touch off to a known Z height. But there are quicker ways of doing this. Some people use probes which are tied into your CNC machine, like a Reassembly. Unfortunately, I don't have anything like that at the moment. Other people find the corner optically using like a centering microscope. But I kind of feel bad doing it like the way I have been, because nearly a couple of years ago, Nikolai Owens, an excellent YouTuber and machine shop owner from Denmark, gave me this Haimer 3D touch-off probe, which when set up can do all three of those touch-off points without changing tools. But unfortunately, I couldn't get it adjusted to work. Effectively, you've got two ways of setting it. You set the whole thing up and down to get the zero in the right spot, and then you center it with these 4 screws around the top, like a forge or chuck, to get it centered on the ball. But I couldn't get it adjusted far enough to get centered without it jamming up. But luckily, my mate Luke from Malta bought a box of about 80 normal gauges and disassembled them all, and he's been doing a lot of clockwork. And he's coming up for a holiday in Vienna and he's going to pop in and visit, so maybe I'll give him a shot at seeing if he can fix this.
Mail time.
Oh, g'day Luke. Welcome to Vienna. Who doesn't have too many indicators? Oh, this is a cutie. Look at this little baby.
Yeah, this is quite a cute one, that one.
Well, thank you very much for your gift of indicators. So you've been buying indicators again?
Oh, well, I never stopped really.
Were these also a lot which were in various condition, you had to break them down, re-clean them, or they all worked as arrived?
Some of them had to clean out. The small one I haven't cleaned out actually yet, but it still works a bit.
Well, it's good that you've been practicing your indicator cleaning, because I've had this on my to-do list for the longest time. This was generously given to me by Nikolai Owens, and when I got it, it was a bit sticky. I played around with it and it sort of unstuck, but it's never been reliable. And then I did the center adjusting and found now it's not working at all. I didn't force anything, so I don't believe that I will have bent anything during that center adjusting, but for whatever reason, it needs to come apart and be unstuck. If there's anyone who's got experience with opening up dial indicators and making them work properly, it's Luke, so please.
Well, I have experience breaking things at least, so hopefully I won't try that out. So let's have a look, see what's wrong with this Haimer probe. Probably looks like something's binding up a bit, so we'll take it apart and see if we can give it a good clean, and probably just some dried up oil and a bit of dirt over the ears. Looks like the dial was in a bit twisted, so it was binding up on the side of the slot.
So now it's working again. The next step is to basically center it like a four-jaw chuck. So turning the Haimer, there is no deviation. So now that you've got it set up, now we'll turn on the spindle at 4000 RPM.
Yeah, I think that would help, eh?
Cool. So, pushing around on the spindle. It's not that much either, is there? It's a pretty rigid spindle.
Yeah.
So the next question is, how repeatable is it? So if I press this away, will it come back to the same point? That's pretty much where I had it, huh? And the Haimer is centered, it's just slightly off axis. The miscentering comes from running out of adjustment on the up-down movement of the dial. With that you adjust that it goes exactly 2 rotations, 2 millimeters for the radius of the 4 millimeter ball. So this should be a 25-50-75 block. Jog. Till we hit. Go around once and twice. There we go. We're zeroing Y. And now we pop over the other side. Oh, I didn't note how high we were, but I guess it shouldn't really matter. It's a square block. Ah, yeah, I see coming up on the 0 mark, yeah. Okay, so that's 0. And with that measurement, we're about 6/100ths of a millimeter off. Oh! Man. I was putting the x-axis into its fully this way position, its kind of sleeping position, and ran the probe straight into my block. Wonder if you can glue those back together successfully. Now while that's damned annoying, luckily back when Nicolaiones gave me this probe, the engineering sciences guy generously donated his spare probes because he wasn't using his anymore. And I think I've been storing them in my gauge collection box. Ah yeah, here we go. 4 of them. I think they're all the same. I think these are made with a ceramic or something, this red bit. At least it's supposed to break off, that's what it's designed for. And I tested it, it worked fine. The ones which the engineering science guy gave me have a different ball diameter. That's 5 millimeters instead of 4 millimeters. Well, after a whole bunch more playing around with it, Luke worked out that the 5 millimeter ball is actually the default ball for a Haimer 3D probe. Because with the 4 millimeter ball in place, we had to move this whole thing right to the very edge of its travel and still couldn't get the 0 mark perfectly aligned. We were sort of off on an angle. Whereas with the 5 millimeter, we could move the whole gauge further back up to the middle of its travel, and now it works perfectly. So all we have to do is put it in, touch off to 0, go to the other side, touch off to 0 again, and then touch down on top to 0. I think I'm going to set this up as my tool 1 in my tool table, so I'll always touch off with all 3 axes with this, and then have my offsets relative to that, and it should be much faster for setup. Nicolaiones and Engineering Tool Guy and Luke, thanks very much for your assistance for getting this to me and getting it working. I really appreciate it. You'll see this in plenty of my future videos, I hope. So that can now come off the leaderboard, because it's a done deal. Oh wait, that's already done as well. Cool. After this video goes live, about a half an hour later, at 1 o'clock Central European time, I'm going to do a live stream. I've done a bit of searching on the internet. There's a wee bit about it on Practical Machinist. But since I've been given this lovely bar of M48 or 1.3207 high-speed steel it's a Bühlerett steel made in Austria. It's 14 millimeter diameter. I need to make a broaching tool with a 10 millimeter shank. Since I've got some polycrystalline diamond or whatever they're called inserts, I figured I'd give it a go and see if we can turn this thing down. See whether the Schaublin lathe is rigid enough for it. So if you're interested, you'll find a Patreon link below, and the link to this video will be on Patreon. Same thing with members. Members can go in through the YouTube members link. Thanks for watching.